Hi students, coming to the next topic, that is representing the scope information in the symbol table. Now let's see, this is the last concept in the symbol table concept. So far we had seen what is a symbol table and how to implement the symbol table and what are the data structures that we used in the symbol table. Now let's see the representing scope information in the symbol table. In source program, every name possesses a region of validity called the scope of that name. So the scope may be declared globally based on global or the local variables. If the variables are declared inside the program, inside the module, so their scope will be up to that module only. Okay, if the variables are declared globally, those variables will be accessed in the entire program. That is the life of that variable. So that we know that there is a scope. The rules in a block structure language is, if a name declared within a block B, then it will be valid only within B. So whatever I said, and the variables are declared within this block means those variables will be accessed only here in the block B only. If B is nested within B2, suppose B1 is nested within B2. So this is the B2 and inside you are having the B1. Okay, let's take B2, again B1. Okay, so if B1 is nested within the B2, then the names that is valid for B2 is also valid for B1. So here B1 and the B2. B2 is nested within the B1. So here the names that is valid for B2 is also valid for B1 unless the names identifier is redeclared in the B1. Okay, the thing is the nested. If the parent block is using the variables, okay, that variables can be used by the child also. Okay, if the child is declaring the variables, it can be used by the parent. Okay, if they are redeclared again. The scope rules needed a more complicated organization of symbol table than a list of associations between the names and attributes. So whenever a new block is entered, then a new table is entered onto the stack. The new table holds the name that is declared as local to this block. Okay, so don't be confused. Let's see the program, then how the table will be, program will be storing the information regarding the scope information. Okay, so let's see. So this is the program, integer x, and this is one function. So inside the function another function will be there. So here there are two functions. This is one function and this is another function. So inside the function there is 1.1, another function is there, and this is element is declared globally. Now let's see the symbol table organization that compiles with static scope information. Static scope information. So the global symbol table. So let's see the global symbol table. So what are the global items here? The global items are x variable, f variable and g variable. So these three variables are the global. So x, y, f, g. X is a variable of type integer and f is a function which having the function. So f is a function of type void and g is a function of type integer. Okay, so this is a global symbol table. Now let's see each function symbol table, that is the function of f and the function of g. The function of f symbol table. So here m is the parameter of type integer and here it is using the x as a variable of float and y as a variable of float. Okay, up to here only. Now coming to the function g symbol table. So n is the parameter of integer type and here the t variable is used. The t is the variable of boolean type. So now coming to the function table symbol table again. So this function f symbol table consisting of two variables x and y, and internally again they are declared two variables. So two data types. So one is I integer of variable I integer and j of variable integer, and next coming to another table u of variable integer and v of variable integer. So this is how the symbol table organization which compiles with static scope information rules. Thank you.